Now, let's talk about notation for the derivative. There are several ways to write the derivative of a function, and all of them mean the same thing. If we write a function as y equals f of x, then the derivative can be written in several ways. The first notation is f prime of x. This is called the prime notation, and it is one of the most common ways to write the derivative. Another way to write it is y prime. This is also prime notation, but we use it when the function is written in terms of y. Another very common notation is dy over dx. This is called Leibniz notation. This notation is useful because it clearly shows how y changes with respect to x. Another way to write the derivative is d over dx of f of x. This notation emphasizes that we are taking the derivative with respect to x of the function f of x. So all of these notations represent the derivative of the same function. Now, let's fill in the statements. The notation dy over dx is called the Leibniz notation. It represents the instantaneous rate of change of y with respect to x. In other words, it tells us how fast y changes as x changes. Now let's talk about what the derivative tells us about the graph of a function. Remember that the derivative represents the slope of the tangent line. So the sign of the derivative tells us whether the function is increasing or decreasing. If f prime of x is greater than 0, this means the derivative is positive. Then the slope of the tangent line is positive, which means the function is increasing. If f prime of x is less than 0, that means the derivative is negative, then the slope of the tangent line is negative, which means the function is decreasing. If f prime of x equals 0, then the slope of the tangent line is 0, which means the graph of f of x has a horizontal tangent line at that point. So the derivative tells us the slope of the tangent line. Now, let's look at the relationship between a function and its derivative. Well, given the function f of x equals x squared minus 2x, from the previous example, we found the derivative f prime of x equals 2x minus 2. The red curve on the graph represents the function f of x. The blue dashed line represents the derivative. The derivative tells us the slope of the tangent line to the red curve at each value of x. In other words, the blue line tells us whether the function is increasing or decreasing. First, notice the blue line crosses the x-axis at x equals 1. This means the derivative equals 0 at x equals 1. When the derivative equals 0, the slope of the tangent line is 0, which means the tangent line is horizontal. If you look at the red curve, you can see that at x equals 1, the graph reaches its lowest point. And if you want to draw the tangent line at this point, it's a horizontal line. So the derivative is 0 at x equals 1. Now let's look at the blue line again. The blue line crosses the x-axis at x equals 1. And when x is less than 1, the blue line is below the x-axis, which means the derivative is less than 0. A negative derivative means the slope is negative. And when the slope is negative, the function is decreasing. So that means my original function f of x is decreasing for all x values less than 1. If you look at the red curve, it's decreasing for all x values less than 1. So the function is decreasing when x is less than 1. Look at the blue line again. The blue line is above the x-axis when x is greater than 1, which means f prime is positive when x is greater than 1. A positive derivative means the slope is positive, and when the slope is positive, the function is increasing. So my function is increasing for all x values greater than 1. So the key idea is the derivative helps us understand how function behaves, whether it's increasing, decreasing, or flat.